Okay, we will see the convolutional how it works. Now, after this, we will do this some basic MNIST data set and we will try to understand. Now, today we are going to build the basic convolutional neural networks, the basic structure of this. See, whenever you wanted to build any neural network in convolutionals, we need to have these are the important the backbone or fundamentals for building a neural network. One is size of the input, shape of input vector, input image. If we are using the color image, if I'll be sharing this, if you are using the color image, we need to specify the channels. We need to specify the channels. The third argument here, 32. Here, first 32 is shape, right? Length and the breadth and number of channels. If grayscale image channel will be 1 and RGB or RGB only, right? It's gonna be 3. Now, I'm just first thing I'm importing. I'm just building a neural network model. I'm just not training. I'm not taking any value. I'm just trying to understand what are the importance, what are the things we need to use for a model building. See, again, here we use the model building as a sequential. The people talks that sequential is to is not to build a sequential model. It's not to build sequential. So don't think that we are deep learning. We are building a feed forward so that I am using the sequential. It's just to initialize your weights. Initialize your initial weights to your neural networks. This will perform the weights allocation to the initial layers. So I should mention the input shape. So here I have taken the color image. So I'll be having the 3 channels. So what is the next step we need to use? Now you see. Now here we'll go one by one. Here let's understand the convolutional layers with 3 by 3 and stride of 2. And one more thing, activation equal to ReLU and comma. This one input equal to shape and we can mention valid equal to either same. What is the option here? I missed. One second. Okay. That only. Here we can mention the padding equal to same or we will do padding equal to same. Now you can see that number of features are gonna retain. So I'm using the stride of 2 so that I wanted to scan the image 2 blocks at a time. The stride will. So why I am explaining you here, when I start one project, one use case now, I cannot go and explain each parameter. First, I am building the fundamentals so that it's gonna be like easy for you to understand the active assignment or whatever hands-on. So stride 2 will lead us to perform an operation by 2 blocks. So this padding equal to same is same means that we are carrying the image to next level with same size. Next level to same size. Either I can have model equal to, here I'll show you the difference. Valid. I'll park this one. I'll show you the figure. We will run this first. Now I'm using the max pooling 2 by 2 matrix and stride of 2. Again I apply the convolutional to extract the features. Then we reduce it. Then we are making the flattening here. We are using either you can use the flatten layer here, or else you can use directly we are moving to the softmax layer. Now you see this.
Suresh, the dense is to flattening or?
We see here. We can use the flatten layer between. So model dot add we will add the flatten layers later. Need to start from the basic. Again, we need to build it here from here. Now you could see the parameters of valid equal to same. So for convolutional, how many parameters we got? For a same, we got 448 here in the first step. When you see valid, instead of this, I will run from here. Again also it is given the same result. There should be some difference in the image. Okay. There should be difference in the image, but parameters will be the same. The number of parameters will be the same, but there should be some difference in the sizes. Okay. Now what I will do, I'll go and execute on one use case, MTCNN, MNIST dataset. First, I will give the background of MNIST dataset. See, MNIST dataset of handwritten digits by Anne Lucon. Actually, he is the author of neural networks. The idea proposed by, and the convolutional is proposed by Anne Lucon. Actually, he is the author of convolutional neural network, father of convolutional neural network. He has collected the handwritten digits of MNIST database, and he performed the operations to identify the the classifying the handwritten neural networks. See, this was his research paper actually. You can go through it, and we can see the test error rate. Neural networks, convolutional nets, everything. So when MNIST, we will see MNIST images. It's a grayscale images. This is what MNIST data look like. This is what MNIST data. So here we are gonna do the implement some handwritten digits classifier. We need to understand, we need to identify the each handwritten. It's a handwritten is in a image that is in a grayscale. Grayscale means what is the channel? Will be 1. So 28 by 28 means how much? 28 square. 28 into 28. When you multiply, what is the total number of values we'll get? 8 8 are 64. 8 2 are 16, 22, 56, 784 pixels, 784 values. I can mention this way also, or I can leave only one channel. Now I will go and perform this MNIST one. The first thing that I need to import MNIST dataset from a datasets library, and we want to import the sequential to build a sequential model, and we have to use two categorical because my output variable we need to have a categorical value. I'll show you that. Sequential and convolutional 2D for what? This is for perform the convolutional operation. This method for max pooling the data, downsampling the data. We will do this downsampling of features, and flattening is to convert 2D into one-dimensional one-to-one. Dense to add a layers, build a network, build a neural network. Activation functions to make the computational faster. Okay, this is what the essential packages I'm gonna import it. Now I'm loading the data into MNIST. Now what I'm doing, I have downloaded the data. If you wanted to see what is the values of xtrain 0, these are your pixel values. This is my one value. This is what complete my data is being storing in a pixel values. What my only and xtrain dot shape. So I have 60,000 images of shape of 28 by 28 because it's in a grayscale image. I don't have the other channels. There is no channel here. Now I'll take the white train. Will be having only one because I have only output. Now I'll check what is white train consists of. It is in a 5, and I'll print white train 540. These are the values of equal. This the pixel value is relevant to this data. What is my output? Right now, I will gonna print x image dot xtrain dot I. I am printing the 9 values. Now you see. 5 digit is 504192133. Guys, would you like to work parallelly so that I can share the code here? Would you like to build a neural network?
Okay.
Or else I'll share the link actually. Otherwise, I'll share the link. Now I have this one, right? And I can see the pixel distributions also. For a image 5, what is the pixel distributions? I have huge values of some values between the 0s to 50, and this is what my pixel distributions is. I have my pixel distribution. Now I'm going to see the building the input vector and 68 by 68, right? So I'm making it as a reshaping it as to 784 and this one. And here is one more trick. I have a values in a given array, given input matrix. given input matrix, I have pixel values from 0 to 255. In order to have reduce the computational intensity, I am making it 0 to 1. I am making it as a 0 to 1. So that is what we are doing with normalization step. So where we perform normalization here. So here we have done the normalization here. We have done the normalization of the data. So when you see after normalization, you will be getting the zeros and ones. Whereas there you can see the pixel values here in the above. You could see the pixel values of somewhere we have seen the pixel values from 225 this way. Now, when I run the pixels distribution now, I will show you. Leave it. I don't have to worry about this. Okay. And I wanted to return the what are the unique values. What are the unique values in the Y train? How many values for 0 is having 59. For 1 I have 67. For 2 I have 59. 3 I have this what the balancing of the data. This will give me the balanced data. So 1 hard encoder of the see I have 0, 1, 2, 3, 4, 5, 6, right? So for a machine learning, what it will do, it will think that 0 is greater than less than 1 and 0 is less than 1 and 1 is less than 2. So in order to make that what we used to have the 1 hard encoding, so that I will be having a 10 by 10 matrix. Now earlier I have the data of 6,000 records. Now I have the 10 by 10. Now I see the Y train of 0. I'll be having 10 values. Now you see. So 0, 1, 2, 3, 4, 5. This is what my fifth record, right? The first record is 5, right? Now my first digit is 5, so that I am having this. Now I will see the second digit. I'll be having the instead of fifth one, I'll be having the first as a 1. See, this is what I'm converted this 1 hard label, 1 hard encoder of the labeling of your output. Okay. Are you able to follow here? Here I'm going to build neural network. Either I can use these many options. Padding and everything. Either you can mention the dense layers, you can use the activation functions, you can build a layer. model dot summary. See, these are these many parameters. Like I have input image of 5112 and 401920. How this has been generated? 5 calculator. 512 into multiplied by 784. This one, right? 41 and plus there are some more calculations been involved, and that will make to this many parameters on each stage. Activation, then dense layer you are adding it again. You are building a neural network. So when you are classifying in 10 classes, right? So I'm using the categorical cross entropy. Why are you using the categorical cross entropy for your images? Now I'm gonna train the images on I'm gonna train it. So verbose 3 will not give any information about your execution process. Verbose equal to 2 will give me some information. We will see that also. So here the verbose 3 is resulting this kind of value. So I'll stop it here. I'll give the verbose equal to 2, and you can see the your loss in the each stage. Loss function, accuracy. This part, first accuracy is in the test data. This this one related to your training, this one related to your testing of data. So because we need to the model, we need to train it and we need to validate on the test data. We are doing on a simultaneously, so that how it is being, it's able to generalize the data. You can able to understand how better it is able to generalize the your model network. Mm. Now we will see we got the accuracy of 97%. Now we can see the plotting of your accuracy and the loss function. So the accuracy on the both loss and everything is similar. It's a very good model. Your test loss is 0.07 and your test accuracy is 0.97% of your accuracy. So we will see the how model is predicted, how model got predicted. Now we are wanted to see predicted class and correctly, and how many predicted correctly? 9,700 got predicted correctly and 2,100 got predicted incorrectly. Now we will see which one is predicted correctly and which one is corrected incorrected. So predicted truth with is prediction classes with y test correct. This is what we have the correct, like we have taken the correct method here, correct indices, the corrected ones. Now I'll gonna show you the predicted is 7, truth is 7, predicted is 2, 2, truth is also 1, predicted is 1, 0, 0, 4 and 4, 4 and 4. Now here, where is this? Here you can see the incorrected ones. Predicted is 8, truth is 3. Predicted is 5, truth is 9. Predicted is 9, truth is 4. Here predicted is 9 but truth is 2. Predicted 5 but truth is 6. These are the some misclassification report. This is what the some misclassification. Guys, are you able to understand this? How to classify? Ravi, Prasad, Satya, Ganesh. Now we will go and see one more like grayscale image of a project that is called one open notebook. One second. I was fashion and mist. I wanted to show mist CNN. This one on the right. Okay. I'll switch to. I'll close this. I'll share you this also. Where is this? Recent one. One second. I'll show you the fashion MNIST. One second. How done? Guys, give me some time. Yesterday I have stored somewhere. Oh, I was searching for fashion MNIST. CNN image one project. I was okay. Here we are gonna do the fashion MNIST clothing classification. Here, like we have seen this also belongs to grayscale image. This is also a grayscale. We wanted to show t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, or ankle boot. These are the things we are gonna classify here. Now we know, right? We are gonna import. We are gonna import the models, import the packages of this one. So here, you know, right? Categorical, optimizer, SGD, stochastic gradient descent. Earlier we have used Adam. So tomorrow we will talk about some more concepts, better deep learning, where we can see we have already discussed optimizers and regularizations, right? Here also we will see what is the optimizers and what were the regularizations we will be using. To categorical, we wanted to have a classes we have will be having 0, 1, 2, 3, 4. So we wanted to convert this as into a, now you can see. from TensorFlow. Keras start data sets import fashion MNIST. We are going to import MNIST dataset. So we have downloaded the data. Now we have 28 and 28. Shape is 1. So that means of grayscale. So I am giving the dictionary 0 for t-shirt, 1 for trouser, 2 for pullover, 3 for this, and I am just gonna plot the sum of the pictures. Can you see? Is this grayscale image or color image? It's a grayscale, right? It's in a grayscale. So here you can see t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, and the ankle boot. Again we will run it differently. Okay. Now formatting the data. We wanted to format the data X-train and Y-train. Now let us see. We also normalize input pixel values between 0 to 1 rather 0 to 225. So that I am doing my normalization here. I am dividing it by 255. That's it for every data. So at the moment, my target vector y-train and y-test represent array values of 0, 1, 2, 3. It means that the model should assume that predicting 1 instead of 0 better than predicting 5. But our labels are actually categorical. The value 0 is to t-shirt and the tops and similarly. So what we are doing, 0, I am placing the values here. It's like 100 encoder for what we did in the earlier case. So now we are converting the classes. Now we are building a sequential input shape. That parameters are optional, stride and everything. If you won't mention the stride and the valid equal to same, it takes the default values. Even I am able to build a model here. Now you see, I have built a model. Model.summary. I have this many values. I'm gonna predict these are the parameters I'm gonna train. 6 lakh parameters I'm gonna train for this neural network. Now here checkpoint is to store the value which is the best accuracy. So you know, right, history, model.fit, X-train and Y-train, validation will be verbose. Validation will be an X-test and Y-test. How many times I am doing it? I am training on one batch size, you know, right? You know the batch size importance. And now I'm gonna see train the model. Model checkpoint. There. Once again, I'll let you search here. So I'm running the model for, like in deep learning, it takes more time. Because you should have some patience at the deep learning. Let it run for some time. So from tomorrow onwards, we'll be working on RGB, color images. You can open in your machines also. And okay. And we wanted to see what the best value we got it also. So this is what my test accuracy, and I'm able to. Here there is something called overfitting and underfitting cases. Is this overfitting? It's leading. We will talk about training error is more and test error is less. It is failing to generalize. So there are some issues here. We'll address these issues tomorrow. How to solve this? We got the best epoch, best accuracy at 23rd epoch. 23rd epoch we got the best. 23rd epoch we got 90% of accuracy. Now we evaluate the model. Y predict, X test. The correct predictions. Are you see? Predicted is ankle boot, actual also ankle boot. Predicted is pullover. I have actual also pullover. Predicted as a trouser, actual also trouser. Predicted is trouser, actual also trouser. Shirt, 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 sandal, sandal. So these are the correct predictions. Now you could see. Predicted is sandal, but actually is ankle boot. Predicted is pullover, it's actually coat. Predicted is sandal. There is some misclassification because my accuracy is only 90%. When I run this classification report, what is my? It's not bad. Like my precision on this 94, bag is 98, sneaker is 94, and see coat is what I have only 81%. Coat it is some classes I'm doing misclassification. So when you can see here, this is what your weighted accuracy. See your total 91. I don't want to explain you what is precision and what is a recall, right? I hope you people are know it. Precision and recall. This is what the today's session. We will see some more like exercises tomorrow. Then we can forward with some difference. We will talk. We will have one more session on this how to do it. Here this is perfectly it's a overfitting. So my training accuracy is more and my test accuracy is less. See now. My training accuracy is 95, and whereas my test accuracy is only 90. It's 95 and 90. So we will address how to solve these issues. Right? Prasad, what it is telling? Okay.
Invalid credentials.
I'll download it and I'll share with you via mail.
Okay, thank you.
Hope you understood the core concepts. Yes or no? Vaibhav, Sagar, Amir. You can unmute yourself and we can discuss. I'll be stopping the recording because this is what we discussed.